Hi, today we're doing an overview of our systemsarchitect.io blog article on the shared responsibility model checklist. Cloud security failures almost always trace back to a misunderstanding of who owns what. Every major provider splits duties between themselves and the customer, but the line moves depending on whether you run infrastructure as a service, PaaS, or SaaS. Get that wrong, and critical layers sit unsecured because everyone assumes someone else is covering them. This checklist covers 10 practices so your team knows and fulfills its side of the shared responsibility model on AWS, Azure, and GCP. This info comes from blog.systemsarchitect.io, and it's a shorter version of the original. I appreciate a like for the video and subscribe to the channel. First, know exactly what you own. In IaaS, infrastructure as a service, you own the operating system, middleware, runtime, data, and application. In PaaS, platform as a service, your boundary shrinks mostly to data and application configuration. In SaaS, software as a service, you still own data classification, access control, and user management. What happens if you misread that boundary? Misreading that boundary leaves whole layers open. Teams sometimes assume the provider patches EC2 guest OS, which they do not, or that managed databases need zero client-side encryption enforcement. Build a responsibility matrix per service across identity, network, OS, data, encryption, and logging, and use assessment tools to highlight missing customer controls. On AWS EC2, it means you own everything above the hypervisor. RDS, it means the provider patches the engine while you own network rules, auth, and encryption settings. On Lambda, it means you own code and IAM. On Azure, Defender for Cloud Secure Score shows how well you meet customer-side controls, and low scores flag real gaps. On GCP, Security Command Center Premium surfaces customer misconfigurations like public buckets, open firewalls, and unencrypted disks under Google's shared fate approach with stronger defaults. Second, document provider versus customer duties in writing. A living matrix survives turnover and answers 3 AM ownership questions without debate. Auditors also expect proof you understand your obligations under frameworks like SOC2 and ISO 27001. Columns should include service, domain, provider duty, customer duty, and a verification method such as a CLI query that proves encryption is on. Review the doc quarterly as services and architectures change. On AWS, artifact reports clarify provider controls, and config conformance packs continuously check your side. On Azure, Compliance Manager lists Microsoft managed versus customer managed tasks with remediation steps and exportable reports. On GCP, assured workloads and security health analytics map findings to CIS benchmarks so customer gaps are explicit. Third, never assume the provider secures your data. Providers secure infrastructure. Bucket contents, database rows, and application secrets are yours to protect. What's actually gone wrong before? Public object storage and application layer flaws have exposed billions of records while the underlying host stayed secure. Prefer account-level guardrails that make bad configs impossible. Block public access org-wide. Force encryption and deny creating unencrypted resources. On AWS, S3 block public access at the account level plus service control policies against public principals. On Azure, policy at the management group for encryption, no public blob access, and HTTPS only transfer. On GCP, organization constraints for uniform bucket access, shielded VMs, and disabling long-lived service account key creation. Fourth, encrypt everything by default. Encryption should be the normal state, not a per-resource option someone forgets. Default at rest encryption plus policies and monitoring form 3 layers. Modern AES 256 with hardware assist costs under about 2% CPU. On AWS, default EBS encryption per region, S3 default encryption on new objects, encrypt RDS at create, and SCPs that require encrypted volumes. On Azure, storage encryption by default, customer managed keys in T-Vault when needed, disk encryption policies, and TDE on Azure SQL by default. On GCP, Google managed encryption everywhere at rest, with Cloud KMS customer managed keys required by org policy for regulated resource types. Fifth, manage identities and keys yourself. Identity and crypto key control stay customer owned in every service model. What goes wrong without federation? Scattered native users without federation leave orphaned access after people leave. Compromised credentials remain a leading breach factor. Federate all clouds through one IDP for multi-factor authentication, offboarding, and audit. Use customer-managed keys for compliance-sensitive data and log every key use. On AWS, Identity Center with SAML or SCIM, KMS customer-managed keys locked to specific roles, multi-region CloudTrail on KMS calls. On Azure, intra-conditional access, privileged identity management, and Key Vault with RBAC and full audit. On GCP, Cloud Identity or Workforce Identity Federation, Beyond Corp style Zero Trust where appropriate, Cloud KMS with rotation and audit logs. Sixth, patch guest OS and applications. In IaaS and many PaaS setups, guest OS and app dependencies are yours. Unpatched systems remain a top exploit path. How fast do attackers move? Exploit time for critical CVEs can be under a day, while many orgs still patch on a monthly cadence. Automate OS patches in maintenance windows and pull dependency updates through CI/CD with clear SLAs such as critical within 72 hours and high within 7 days. On AWS, Systems Manager, Patch Manager, baselines, and maintenance windows with compliance dashboards. On Azure, Update Manager for Azure and Arc machines with scheduled configurations and pre-post scripts. On GCP, OS config patch jobs and policies, plus inventory of installed packages across the fleet. Seventh, secure all network traffic. Logical network controls are always customer-owned. Security groups, NSGs, firewalls, VPNs, and private connectivity. The provider owns physical network and hypervisor. A wide-open SSH to the world is still on you. Default deny open only needed ports to specific sources or adjacent security groups. Encrypt and filter east-west traffic and use flow logs to verify expected paths. On AWS, security groups and network ACLs, VPC endpoints for private service access, flow logs, and transit gateway for inspection hubs. On Azure, NSGs and application security groups, private link for PaaS without public exposure, and traffic analytics on flow logs. On GCP, VPC firewall tags or service-to-account targets, private Google access, subnet flow logs, and packet mirroring when you need deep analysis. Eighth, enable provider security features. Why turn on provider security features? Built-in logging and posture tools are free or low cost. Leaving them off is like installing an alarm and never arming it. Day zero for every new account should turn on org-wide trails or activity logs, threat detection, posture management, and default encryption, automated with Terraform or stack sets. On AWS, multi-region CloudTrail, Guard Duty, Security Hub, and config from the management account. On Azure, Defender for Cloud free assessment plus paid plans where needed, diagnostic settings to log analytics, and advisor security recommendations. On GCP, Security Command Center at org level, admin activity logs by default plus data access where required, and access transparency for support access visibility. Ninth, review the model during every design. Adopting EKS, Elasticache, or any new service shifts who patches, who encrypts, and who configures the network. Add a security responsibility review to every design. List customer duties per service. Get a security pass before approval, and record decisions in architecture decision records. On AWS, well-architected security pillar reviews and milestones track posture over time. On Azure, well-architected assessment maps gaps to concrete services and backlog work. On GCP, architecture framework security checklists and foundation blueprints bake defaults into landing zones. 10th, train the team on shared boundaries. Tools fail when people still think the cloud is fully managed security end-to-end. Most cloud incidents involve human error on customer-side config. Quarterly workshops with breach case studies and hands-on labs build the habit of asking, who owns this layer? Use free paths, AWS Skill Builder, Microsoft Learn, and Google Cloud Skills Boost security courses and labs. To close, know what you own and write provider versus customer duties so misowned layers stop becoming silent gaps. Encrypt by default and keep identity and keys under your governance so data stays protected even when infrastructure is stressed. Patch on schedule, default deny the network, and turn on the security features the provider already ships. Review responsibilities in every design and train people so shared responsibility is a continuous practice, not a slide from onboarding. Those 10 practices close the ownership gap that drives so many cloud breaches on AWS, Azure, and GCP. Well, that does it for now. Hope you got something out of this video. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io. That's systemsarchitect.io and codeguides.io.